Imagine holding a physical object in your hand, moments after it existed only as a digital file. This is not science fiction, it's the reality of today. This is the power of 3D printing, a revolutionary technology transforming the landscape of manufacturing. From simple tools to complex machinery, 3D printing is reshaping how we create. Also known as additive manufacturing, 3D printing constructs three-dimensional objects from digital designs. It's a process that starts with a digital blueprint and ends with a tangible product. It achieves this by meticulously layering materials one on top of another until the final product takes shape. Each layer is precisely placed, creating intricate designs that were once impossible to manufacture. This groundbreaking technology has evolved significantly from its early days of basic prototyping. Today, it's capable of producing highly detailed and functional items. It is now a driving force in diverse industries, from aerospace to healthcare. In aerospace, it's used to create lightweight, durable parts, while in healthcare, it's revolutionizing prosthetics and implants. 3D printing empowers creators, engineers, and manufacturers with unparalleled design freedom, rapid prototyping capabilities, and the ability to produce customized goods with incredible precision. This means faster innovation and more personalized products. This revolution in manufacturing is changing how we design, prototype, and produce. It's making the impossible possible, and it's only just beginning. Ushering in a new era of innovation, 3D printing is not just a tool, it's a catalyst for change, driving us towards a future where the only limit is our imagination. 3D printing offers a compelling array of advantages over traditional manufacturing methods. This innovative technology is transforming the way we think about production and manufacturing. These advantages are driving its rapid adoption across industries and revolutionizing production processes. From aerospace to healthcare, the impact is profound and far-reaching. One of the most significant benefits is cost reduction. By minimizing material waste and reducing labor costs, 3D printing offers a more economical solution. Traditional manufacturing often involves expensive tooling and molds, making it costly for small batch production or highly customized designs. This can be a major barrier for startups and small businesses. 3D printing eliminates the need for such tooling, significantly reducing upfront costs. This democratizes manufacturing, allowing more players to enter the market. This makes it an ideal solution for producing prototypes, customized products, and even small to medium-sized production runs. The speed and efficiency of 3D printing are unmatched. Furthermore, 3D printing offers unparalleled flexibility and customization. Designers can bring their visions to life with ease. Designers and engineers can quickly modify and iterate on digital designs. This agility is crucial in today's fast-paced market. This allows for the creation of highly customized products tailored to specific needs and requirements. The possibilities are virtually endless. This level of customization opens up a world of possibilities, from personalized medical implants to bespoke automotive parts. The future of manufacturing is here, and it's additive. The world of 3D printing encompasses a variety of technologies, each with its unique strengths and specific applications. These technologies have revolutionized manufacturing, enabling the creation of complex designs that were once impossible or too costly to produce. Understanding these technologies is key to harnessing the full potential of additive manufacturing. By grasping the nuances of each method, one can choose the most suitable technology for their specific needs, whether it be for rapid prototyping, custom manufacturing, or large-scale production. Fused deposition modeling, FDM, is one of the most widely used 3D printing technologies. It is favored for its simplicity and cost-effectiveness, making it accessible to both hobbyists and professionals. It works by extruding a thermoplastic filament through a heated nozzle. The material is deposited layer by layer, solidifying as it cools to form the final object. The nozzle moves precisely layer by layer to build the object. This method is particularly useful for creating prototypes and functional parts quickly and affordably. FDM is known for its affordability, ease of use, and suitability for prototyping and creating conceptual models. It is a go-to choice for many due to its versatility and the wide range of materials available. Stereolithography, SLA, is another prominent 3D printing technology. It is renowned for its ability to produce highly detailed and smooth parts. It employs a highly precise ultraviolet UV laser to cure liquid photopolymer resin, building objects layer by layer. This process allows for exceptional accuracy and fine details. SLA excels in producing parts with intricate details, smooth surface finishes, and high accuracy. It is ideal for applications requiring fine features and a high-quality finish. Selective laser sintering, SLS, is a powerful technology for creating robust and durable parts. It is widely used in industries that demand high-performance materials. SLS uses a high-powered laser to fuse small particles of materials like nylon, creating solid, three-dimensional objects. This method is particularly advantageous for producing parts that need to withstand significant stress and wear. Section 4. The role of software. While 3D printers are the engines of additive manufacturing, computer-aided design or CAD, and computer-aided manufacturing or CAM, software are the brains behind the operation. CAD software enables designers and engineers to create intricate 3D models on their computers. These digital designs serve as the blueprints for 3D printing. Popular CAD software packages such as Autodesk Fusion 360 and SolidWorks offer a comprehensive suite of tools for creating, modifying, and refining 3D models. Once the 3D model is complete, CAM software takes center stage. It converts the digital design into a format that the 3D printer can understand. This involves slicing the model into thin layers and generating precise toolpaths for the printer to follow. Section 5. Transforming industries. The impact of 3D printing is being felt across a wide range of industries. From aerospace to healthcare, additive manufacturing is transforming production processes, enabling innovation, and disrupting traditional business models. In the aerospace industry, 3D printing is used to create lightweight components for aircraft, reducing weight and improving fuel efficiency. Aerospace giants like GE Aviation are leveraging 3D printing to produce complex parts, such as fuel nozzles for jet engines with increased efficiency and reduced lead times. The automotive industry is also embracing 3D printing for rapid prototyping, tooling, and even the production of end-use parts. 3D printing allows automotive manufacturers to create customized car parts, such as interior components and personalized design elements, catering to individual customer preferences. Section 6. Market growth and future trends. The 3D printing market is experiencing exponential growth, driven by increasing demand from various industries, technological advancements, and a growing awareness of the benefits of additive manufacturing. The future of 3D printing is bright, with continuous innovation and development pushing the boundaries of what's possible. Researchers and companies are constantly exploring new materials, improving printing technologies, and enhancing software capabilities. One exciting trend is the development of new materials for 3D printing, expanding its applications even further. Researchers are experimenting with bioprinting, using 3D printing to create living tissues and organs for medical transplantation. Section 7. Conclusion. Shaping the future. 3D printing is more than just a technology. It's a paradigm shift in how we approach design, manufacturing, and innovation. Its impact extends beyond factories and research labs, empowering individuals, entrepreneurs, and businesses of all sizes to turn their ideas into tangible realities. As we venture further into the 21st century, 3D printing will continue to shape the future of manufacturing, enabling us to create lighter, stronger, and more sustainable products. It will empower us to personalize products, reduce waste, and push the boundaries of human creativity. The possibilities are limitless, and the future of making is in our hands.